Hi, I'm Buddy Lindsay, and I am going to start doing a weekly stream on learning how to do Rust. I've never done any streaming before, and apparently you have to apply to do that 24 hours before you do it on YouTube. So I'm actually waiting on that. So tonight I am pre-recording it, and I'm going to go ahead and upload it. I have never done anything like this. Most stuff I do is pre-recorded and lots of editing. So it shall be interesting. So let's get into who I am and what is going on and how does this relate to Rust. See, there we go. So Rust, I am Buddy Lindsay, and I currently work for a company called Nifty Gateway. They're a subsidiary company of Gemini. I'm a software developer, and I mostly do Python and Django. I have done Django for over a decade now, even ran a site, gojango.com, that basically taught people how to do Django. I used this site to help learn and get started in the beginning, and then I turned it into actually teaching people how to do it and setting it up on a subscription-based website. This actually got okay, decently successful, and I just got burned out from it because I just had a baby. I was trying to finish my college degree, and I was working full time, and I had an hour commute each way. So it was just, I was getting burned out, and something had to give. And so I pulled the plug on GoDjango and just went back to daily dev. However, I've been doing Django and Python for a decade now. It took a 1 year hiatus and did Node.js professionally, but then we converted over to Django. So in a sense, I never really left Django to a degree. However, moving forward, I would like to learn Rust, and I have not done a very good job of actually diving in and learning Rust, and so that's what this channel is about. That's why I'm starting GoRust. It's not at this point going to be like GoDjango, where I do small, short little videos. I intend to try to do a weekly live stream, preferably on Monday nights. We'll see how consistent I can get about that. And basically, it's me walking through learning Django, or learning Rust. I've done a few of the tutorials. I've walked through a little bit of a book. I've done some of the katas, and so I know a tiny bit about it. The problem is I'll start for a little bit, and I don't really have anything to work on, and it just kind of all goes away because I don't have any fun and interesting projects to work on. And I have nothing to help keep me coming back. And so this is kind of a social proof, social experiment, social whatever to kind of keep me coming back and doing it. Because it is something I want to learn. And I think between Go and Rust, we're not going to learn Go here as far as I know. These are Go and Rust are the languages of the next 20 or 30 years. Python and Django are not going anywhere at all. But I would like to learn Rust and get into more lower level programming. I am super interested in more systems level programming. It just seems more interesting. I like that area. And so that's the area that I want to work on. So with that in mind, what are we going to do? I currently have another YouTube channel. It is Lindsay Acres Farm. And it is where I do most of my stuff. On the side, I do DIY stuff, and I enjoy doing that. Woodworking, homesteading stuff. I'm currently working on restoring a golf cart and getting that worked out for doing stuff around the farm. It's what I enjoy doing in my off time. And as part of that, I have a couple of utilities that I've written in Python. And I was like, hey, that would be a good opportunity to get started learning Rust, is to maybe write those things in Rust. So what are those things? The most basic is I use basically AI, chat-gpt, to help me come up with ideas for titles and descriptions. I kind of help it generate a few ideas, and then I go through and modify from there to get a not quite as clickbaity, because man, chat-gpt loves clickbait, and I don't necessarily like it. So, see, that was a pause that I'm used to doing when I record a video. I'm not used to the live stream thing. So this is going to be a fun and interesting experience trying to do this as a live stream. I am currently 4 minutes in, and we've actually not done anything. So, the final of what we're going to do in Rust, and we're going to get started in that tonight, is my main Python application as of now is it queries YouTube, gets the for a search term, and it gets titles. And And that's really it. That's kind of all it does. It gets titles and then some of the metadata about those videos so that I can then take that data, throw it to chat-gpt, and have it pop out a result. So from that, I have not thought about how to do that in Rust. I have not pre-planned anything. I don't even have a project started for that. And the only thing on this system that exists is I have Rust installed, and I went ahead and updated it right before this to the latest version of Rust up. So it's going to be kind of go from scratch and figure things out as we go. And I will try to have that discussion along the way. One thing that I am going to do is I'm going to use AI to help me learn. And specifically, I'm going to use Find. And it uses ChatGPT 4 on the back end. I use ChatGPT. I pay for it, and I use it all the time for stuff. I find this good more for programming. ChatGPT does a really good job. I feel like they're at Find, they do a little bit something extra, and it makes it more interesting in finding results. So with that in mind, let's go ahead and get started. The first thing that we need to do is we need to start a project. All right, so let's go over here to Rust. And again, it's been so long, like I don't really remember how to start a project. So we have it installed. So let's go ahead and open up Visual Studio Code. I'm going to try to keep everything in Visual Studio Code. I'm going to use its terminal, and I'm going to switch back and forth for the browser because I don't want to open up too many windows and have everything get confusing and lost. So with that in mind, I have my Programming Rust streaming folder, and we're going to see about using that. So let's see if I can do cargo init. Okay, so that creates a new project in the current directory. Let's go ahead and kill all that. Yeah, we don't want to do that. Git cargo rmrf source. Okay, we're cool. All right, so let's do cargo init. One of the things that I did when I was learning Django is I would just do a bunch of simple projects, and I wouldn't try to like mash everything together. That got me really good at setting up new Django projects and kind of getting through that really fast, and then also focusing on just one thing inside of that project. So I think I'm going to do something similar, and so let's do cargo init, and I think this will work. API request. Yeah. See, there we go. API request is a folder. We can expand that. There we go. So if we'll just go in here and we'll open our source file. Nice, nice. See, cargo build. Nice. Cargo run. Nice. Hello world. We're getting there. We're getting there. We're making things happen. This is exciting. So now let's go in here. Let's go ahead and let's just close everything to the right. Whoop, nope, because I don't want that. Close tabs on the right. All right. So cargo search, cargo crates.io. That's what it is. All right. I think it's request. I can't think of what the thing is. There's a request. That's not it. So let's go with find.com. See, this is where AI starts. What is the community standard packet crate in Rust for making API requests? But it's REQW. Yeah, I just remember that. All right. So, request. Cool. So, let's go to request. Awesome. There we go. This is an asynchronous example using Tokyo. I am not planning on using Tokyo at the moment. I just want to do the blocking. There's optional blocking client API that can be enabled. Okay, let's do this. Because again, this is just about like making requests to something and then us being able to see that. So we'll go cargo.toml, save that, and cargo build. Cool, it's getting all the stuff. Ser, Tokyo, URL, ID name, OpenSSL, awesome. So it built it all in there. All right. So we can actually go back to the example here. Now let's just copy this. No, actually. Hash map string. It's going to get JSON. I don't know if that's what I want. Here, we're going to do this. Oops. Oh, crap. Okay. So let response equal. So we actually want a return type of result. I wonder what the box is. See, again, like I'm trying to learn what this is, and I'm not necessarily in the best position here. Dang it. Okay. So something that's going on is I don't have my normal keyboard that I use for programming it, so I keep hitting the wrong buttons. So this is my normal keyboard that I use at work, like that, and it's great for programming and great for everything I do. However, for all of the other stuff that I do, I use this one on my personal computer, which this is on, and this is great because it gives me more keys to work on video editing and the other things that I do there. So that's kind of where I'm going to have some serious weird typing going on, and I think it's going to not be great. So what I probably am going to need to do at some point is plug this keyboard into my main computer or my personal computer and use that. Okay, I'll bet this is an error about not reach syntax error. Oh, there we go. All right, response equals, and we're going to do request blocking. And we'll get to where we do more async stuff, but just at the moment, like I'm not really wanting to do that. So let's go ahead and what's the Star Wars API? Swappy.dev. All right, and I want ships. I don't want people. So ship one. Oh, starships. There we go. All right. Starship /1. Okay. So we save that. And then we can use this blocking get. Oh, that's cool. So let's try that. Dot text. So then, oops. So what does text do? Get the response text. This method decodes the response body with the bombs. If I move, okay. Why are we erroring here? Oh. get I gotta get standard error here. Cannot find value response in this scope. Dynamic error. Oh, okay. I was pulling this in normally without having to do an import. Okay, makes sense. So response. Let response request blocking get URLs. Is that's fine. You know what? Let's do this. I don't understand this error. Can I find the value and let's do cargo build. Not found in this scope. Oh my gosh. See, that was a Pythonism that got me. It's one of the, oh my gosh, I feel so dumb. Okay. Cargo build. Cargo run. Awesome. Oh, status 404. Swappy.dev. Oh, starships. All right. Oops. Terminal. Okay. Schema is HTTPS. Cannot be a base. Swappy, API starships, query none, fragment. API. I mean, swappy.dev/API/starships. Request. Interesting. I did not expect that. Like, there's not a 1? That's crazy. Okay. All right. Let's see. So let's come back here. R5. No, let's do R3. $200. Okay. So we got so response URL blah blah blah. Swappy 300 status 200. Awesome. Okay, now that we got that, let's get .text. This method decodes the response body with the bomb sniffer. Okay. So we save that. Let's cargo run that. And there we go. Star Destroyer and player. Okay, nice. Interesting. I'm not going to spend too much time reading that because I would get a little sucked in. So let's do we have a JSON? Yeah. So response body as JSON using SERD. So we would need this derive requires SERD. Use SERD. And that. Okay. So I think this is a key part to learning a new language, is getting used to using the library. In this case, I am not used to the libraries that are here. I am not used to importing things. So this is going to be a constant frustration, is I'm going to have to constantly look this back up. Use ser, deserialize, and serialize. Okay. So let's come here. And eventually, I'll copy and paste and see this enough that I no longer have to do this over and over and over again. Why are we still... Sared was a dependency. Oh, I wonder if I need to add it to cargo. So let's copy that. Cargo. And now let's come back up here. Ser deserialize. That's what I thought. Some detail, some errors. So detail. API request generates one warning. Could not compile API request due to 2 previous errors. Oh, use standard error. Okay. Okay. Not applicable. Okay. So this is something I've never really understood about using Serd for serializing and deserializing when I play with it. So let's go to an overview of Serd. So there's a framework for serializing and deserializing Rust data structures efficiently and generically. The Serd ecosystem consists of data structures that know how to serialize and deserialize themselves. Actually, so here's where using AI comes really nice. So let's go with, I am wanting to use Serd for deserializing JSON data from a request, from a GET request, but I am unsure how to do that and the specifics of how Serd actually works. So I usually will pose something like this because the documentation is great and I really like it. But sometimes like there's just too much information in here. And I just get lost really fast and it's like I just need something quick and easy. So like here we have struct, awesome. There's a lot of information in there. And I would get really confused really fast. Like this doesn't help me get a request from an API, convert it to JSON. Like now this is great for trying to understand Serd at the very basic level. Like, and this is something that I want to learn at some point. But sometimes when you're learning, you just want to see something work because there's some power in that, and it's nice to really get that. So that's really what I'm after. I'm wanting to get some super basic examples to just work, and then I can build on the knowledge of that. Like if I can just get a few things to work. Okay. So we have a struct. So we're deriving debug, serialize, and deserialize. Okay, here we go. To use Serd for describing JSON data from a GET request with the request in Rust, you first need to define a struct that matches the data structure you expect to receive. Makes total sense, obviously. This struct must implement the deserialized trait from the Serd library. You can derive this trait automatically with the derived serialize attribute above your struct definition. Here's an example where we define a product struct that matches the hypothetical JSON structure. So we are, okay, so this is, okay, I just want to double check here. This struct must implement the deserialized trait from the Serd library. You can derive this trait automatically with the derived, so, okay, so I have a question that I want to ask it here in a minute. So actually, I have a couple of questions. Now I'm going to try to avoid hitting enter on these yet. Can you please answer them? Answer each of them. One, I know that we don't have class inheritance in Rust. Do traits fill that gap in the sense that you can use the derive and attach functions to a struct or other data structure to expand the functionality? So this is another reason I really like doing AI stuff, is because this question makes sense to me, may not make sense to a lot of other people, but depending on the answer I get back from this will help me understand and try to get back and learn Rust a little bit faster. So there we go. So we have question one. So in this case, Sarah, rename all equals camel case. That's interesting. It's probably, that's cool. If it does what I think it does, we'll see. Once you've defined your struct, you can use the JSON method on the response object to deserialize the JSON data into the struct. Here's an example of making a GET request and deserializing the response. So, winner main. So request.get await. So that's just the async JSON await println product. What? Oh, so I guess we're casting it to a product struct there. And so it knows how to handle that. Interesting. Okay. In cases where the structure of the JSON data is unknown or varies, you can use the shared JSON value to hit arbitrary JSON data. So in this case, we're going to use this because I'm not going to be 100. Excuse me. In this case, we're going to use this because I don't want to define yet the struct for the data coming about from the starships. And its second implementation, I want to go ahead and do that just for the practice, for the repetitions. And that's part of learning on some of this, is you got to get your reps in and try to start from the basics. And that's what we're doing today. So we're looking at the request library. We want to make requests to API, third-party APIs. We want to get the response data back, and then we want to write that out. So, doop-a-doo. Remember to add Serd and Serd JSON to your cargo.toml dependencies. There we go. Okay, cool. So really, I only have, I think, one main question from this that I want to get an answer about. I think we're pretty good. Oh, actually, here's another one. If I defined another struct for the JSON serialization, take the product struct as an example. And move the thumbnail and images properties to a to some sort of metadata struct, because they are kind of because they are JSON objects that are nested. How does that look? That's another thing is I kind of have in my head, but I don't want to be too obvious in what I mean. I don't want to be too descriptive and tell exactly the system what I want. I don't like to do that. I like to try to let it infer, because sometimes I'm thinking about it wrong, and they always give very, very good detailed descriptions, and I can learn some extra stuff from those descriptions. So I like to keep it vague and see how it interprets it, because if I can keep it vague in some cases, that means have the generalized understanding. If I get too specific at times, I have a bad response and I just confuse myself. So I think this is probably a little too vague, but let's see what the response is from this. We should get we should get both of them answered. So let's see, answer. All right. Traits in Rust indeed fill the gap in class inheritance. Fills in other, like, cool. That's exciting. That was something I did not realize before. They allow you to find shared behavior across multiple types, similar to the interfaces in languages like Java and TypeScript. However, unlike class inheritance, traits in Rust are not tied to a particular type hierarchy, and cannot be implemented by any type. This makes traits more flexible. Oh, and can be implemented by any type. I read that as cannot, and that got really confusing. This makes traits more flexible and powerful than traditional inheritance. You can use the derive attribute to automatically generate implementations of certain traits for your types. For instance, you can use the derive serialize deserialize to automatically generate implementations of the serialize and deserialize traits from the ser library for your struct. This allows the structure to easily convert to and from JSON and other formats, blah, blah, blah. To move the thumbnail and images properties to a separate metadata struct, you would first define the metadata struct and then include that in the product struct. Here's the example. There we go. That's totally what I thought it would be, but I just wanted to check. In this example, the JSON representation of the product would include the metadata field that contains the thumbnail and image fields. And when you deserialize the JSON object into the product, the thumbnail, and the images field, blah, 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 blah. I think we're pretty good. That's exactly what we expect. You're basically re-implementing the JSON as Rust structs, which is what you do. It is a thing that you do. All right. So with that in mind, actually, I want to go a little further with the traits. Can you give me a super simple example of a trait implementation and adding it to a couple of different structs with the derive? Nothing too complicated, so I can see a basic example. So the reason I'm trying to keep it simple in this case is because a lot of times I love tutorial and document writers, but like I said before, sometimes we get a little too complicated and we want to throw all the features in at one time, and it gets really, really, really confusing when we do that. So here we go. Sure, let's start with a simple example using the debug trait with the derive attribute. This trait allows us to print our custom types for debugging purposes. First, let's define two simple structs. So we have a point and we have a line. Makes sense. Oh, point XY, okay, and the line is starting in. Okay, cool. We put derive. So in these definitions, we've added the derive debug attribute above each struct. This tells the Rust to automatically generate an implementation of the debug trait for these types, which allows us to print them using the blah format specifiers with the print line macro. Now let's create an instance of each, blah, 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 blah. So this is not what I wanted it to do. I know this is kind of turning into a lesson in how to use AI. But again, this is a way that I like to learn. In this case, it's actually really, it is descriptive in what it does, and it does help a little bit, but this is not what I wanted. See, and I like to be nice to AI just in case Terminator ever happens. I like the answer, but I was curious if you could create a trait from scratch that a couple of structs would use to get an idea of how user-created traits work along with deriving them. So one of the reasons I'm going down this little rabbit hole now is a big part of Rust, from what I've seen, is deriving traits from other things. And so I feel like getting a better understanding of how that works and how it all attaches to each other will really make it a lot better in implementing in the future. And that's why I like to take some of these rabbit holes when I can. Okay. Let's see. All right, let's go. Absolutely. We can create a custom trait and apply it to multiple structs. Let's consider a simple scenario where we have structs representing different types of animals, dog and cat. Cool. It's funny. I used to rail against dog, cat, person, whatever, because it usually does not help in examples. I like to see business logic. I like to see implementations and examples as business, scenarios. But every now and then you run into something that actually makes sense, as that is basic enough of a concept. In this case, I think it's going to work. First, we define a make noise trait. Okay, so we use the trait keyword, make noise. It's going to have a function, make noise. All right, next we define a dog and a cat struct. Awesome. Now we can implement the make noise trait for both dog and a cat. Okay. So we implement make noise. Okay. Finally, we can create the instance. Interesting. So this is a perfect example of me not getting what I exactly wanted, but actually getting what I needed. I was not thinking of this as a implementation as an interface for the make noise to the dog and cat struct. I was actually looking at this because I want, and I'm still going to try to get that out of it, but I did not realize this. And so this is really good information. I am glad that I went down this rabbit hole. Okay. Cool. Cool, and that makes sense. But however, I am a little off. However, you are a little off from what I was wanting. I want to see a trait implementation similar to how Sared deserialize works, where it is an implementation somewhere else, and we use the derive method, derive ability of Rust. I gotta be careful sometimes because I don't like method has a very specific thing in a programming context, and I don't want to say method and then AI thinks that's what I'm saying. Contextually, it should get it, but I still like to be careful. Derivability of Rust to add that implementation to the struct. I think expanding on the make noise trait makes sense. Sure, let's create sound maker that represents something that can make a sound. So trait function sound, derive sound maker, struct dog cat. Okay, cool. Implement sound maker for dog, sound maker, That's still not doing. Rust currently does not support automatic derivation of custom traits. The derive attribute only supports a few specific traits, like copy, clone, equal partial, and serialize. The derive attribute cannot be used with custom traits. Instead, you have to manually implement the trait for each type. So I'm not sure I understand that last bit. I mean, so in a sense, in this case, we change it over to doing the struct implement up here, the implement make noise for cat, to be derive to the sound maker. I mean, it makes sense. I mean, it should work. Interesting. I mean, that's a good, interesting alternative on how to implement it. I like that. But how does... I don't understand how Serd can add... Let's ask that. I guess I am still confused. I don't understand how you can use derive. Let's actually copy the line. On a function and it properly deserialize. Well, actually, let's go back. Let's make sure I'm not getting a false issue here. Let's go way up. Tokyo main. Okay. JSON. Okay. So we're actually potentially doing it wrong. Derive. Yeah, okay. Okay, here we go. Here we go. Got it. I guess I'm still confused. I don't understand how you can use derive, deserialize, serialize on a struct. Let's just go with that for now. And it adds the implementation that is needed. What I suspect is happening is we have these here. Copy, clone, equal, partial equal order. I think what's happening is there's an implementation in Serd of these, maybe. And actually, I don't know. Reading through that again, I'm confused again. All right, let's just keep going. On a struct, and it adds the implementation that is needed to that struct if, as you said above, the trait we created can't automatically derive an implementation. We'll see what it does with that. Let's see. Okay, there we go. I apologize for the confusion. A very chat-gpt thing. So they don't, syntax does not automatically implement the deserialize and serialize traits for you on the struct. Instead, it generates code that implements these traits for your structs. Yes, I get that. The Serd crate uses a feature of Rust called procedural macros to achieve this. Procedural macros are a way of defining reusable chunks of code that can operate over Rust syntax trees. Okay, so it's crossing the bridge here of macros and traits. In the case of Serd, it defines a procedural macro that takes your struct and generates the necessary code to implement the deserialized traits for it. Here's a simplified view of how it works. You annotate the struct with derive. The Serd procedural macro runs and gets the syntax tree of your struct. It generates the code to implement the deserialized, serialized, blah, blah, blah. The generated code is inserted into your program during compilation. Yeah, I mean, I kind of roughly remember that. See, the process is entirely automated and happens behind the scenes. It's why you can use this without having to manually implement those traits. The actual implementation of serialized traits is quite complex and involves handling various edge cases and optimizations. I get that, but in general, it involves blah, blah, blah. Okay, cool. We're getting a little bit further. Can you take the sound maker trait and the dog and cat structs and create a macro that generates the same code on compilation, similar to Serd, and deserialize? so that if I add the derive to the cat and dog structs, it does its thing, because I'm running out of words. Let's see what happens. This is kind of annoying, this like overlay here. So let's see what we get. All right, sure, we can create a custom derive macro to implement the SoundMaker trait for the dog and cat structs. This is a more advanced topic, but here's a simple example. First, let's define SoundMaker. That's interesting. Then we'll create a custom derive macro for SoundMaker. Oof. Okay. I'm gonna let's just look at this a little bit. Let's see. We're gonna get token stream. Man, this is rough. But let's expand quote. That's cool. Input parse macro input as derive input and I think I just like jumped into the deep end on this one. I'm not even sure what's going on here. All right. SoundMaker derive parse macro input. SoundMaker for Okay, sound function. Okay, so implement. Okay, here we go. Implement SoundMaker for, and I'm guessing this is going to be whatever it is that we're going to work on. We're going to implement the function sound, unknown sound, for that thing, and then token stream. Okay, I'm not going to look deep into how all of this works, but I think this is our little thing. Like, I think this is the part that's going to generate it and inject it into our code once it's compiled. All right, and this code is SoundMaker derive. What? SoundMaker. Okay. Whatever. All right. A token stream as an input and returns a token stream as an output. Kind of like a middleware. It sounds like. The input token stream contains the tokens of the struct for which we implement SoundMaker. The function parses this input into a derive input struct, extracts the name of the struct, and then generates the code to implement the SoundMaker. Blah blah blah. Finally, we can use. There we go. That's exactly this is exactly what I have been after in trying to understand the derive with traits and how that works. That actually, so this kind of pulls back some of the magic of Serd for me. I'm like, I just don't understand what's going on. So at the end of the day, Serd with the derive is using a macro to implement the stuff for it and putting that into the final binary. So that makes sense. And also, traits can be used kind of as an inheritance type thing, as in an interface. So we say, hey, we have these particular functions on there because we are implementing this trait. And we have a couple of different ways to implement that trait. Okay, makes total sense. I like where we went on that one. So let's go back a little bit because I think we're ready to get back to some of our programming. I just want to point out the reason I like using AI in this is because this explanation that I just went through would not come from a document. It would have to come from a blog post, and someone would have to very specifically like detail this out, and most people don't do that. That's the stuff that I like to do in learning. But it is not something people would normally do. Just wanted to kind of point that out. So if you're into making tutorials and you want to be successful making beginner content to intermediate content, what I like to call beginner-mediate content, it's where I focused GoDjango is right there. You already know the basics of programming, and now you're trying to get to that intermediate level, so I call it beginner-mediate. That's really where it stands, is you take complex things and you break it down into sections. Like, what is this thing? What is this thing? What is this thing? How did you go from point A to point D? And in those steps along the way. If you can follow those tracks, you can't jump from A to D. You have to go A to B, explain how you got there, B to C, explain how you got there, and then C to D. And as long as you can do those steps, you're golden. Anyway, enough lollygagging here. All right, so we want shared JSON value. So in this case, so that's going to be so let's do this, do this. Box dynamic, shared, okay. We want to do crates.io. Crates.io. Shared. So this is actually a complaint I have in general about a lot of programming languages, is like knowing what in the world to implement where and when. Like, how do you know what dependency to pull in? It's one reason I really like Python, is because you have to actually import the thing. And it is bad practice in order to do an import star all. There are a very few tiny times that is the right thing to do. But usually you're wrong if you do it. So there we go. So let's go back up to here. Like I am totally, like something is totally off here. There we go. There we go. Now let's see what we get. Cargo built. Nice. Cargo run. Nice. 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 Okay. Cargo capacity, consumables. What that consumables is 2 years. I guess I can carry 2 years of consumables. 47,000 people. What is this thing? Star Destroyer. 47,000. You know, and in one of the previous Star Wars movies, I mean, they had like a couple hundred of these. Like, that's like 4.7 million people just to crew. Like, I guess there's probably trillions of life forms that can run it in the future. But I think like the Empire is supposed to be racist and only humans, and so I don't know. I guess not all crew. Okay, I'm gonna stop with that whole thing because that could really go bad on a tangent there. All right. So cool. We have this. It's running. We're getting our result back. This is kind of where I wanted to get. And then let's do a final thing. Let's copy. Let's go back over here. Let's go to a new one. Here is some Rust code I am learning to write. Can you make this more idiomatic, and maybe what could I do to improve this code? Boom. So I like to do this with a lot of different code. Even in Python today, I'll write out some code that I think is okay, and I'm like, something seems a little bit off, so I'll just copy and paste that code or a version of it, and I'll be like, hey, how can I make this better? Am I doing anything off? And sometimes it'll give me some really good results. So I like to just kind of pop this in every now and then to see what happens. So let's see what we get. All right, here is some Rust code. I'm going to All right, let's see. To make your Rust code more idiomatic, you can consider the following improvements. Use anyhow for error handling instead of returning the box dying error. You can use anyhow results. Okay. For the return type of any fallible function, this will allow you to provide custom context to errors without having to define custom error types. The anyhow library can convert most errors such as they just work. However, only use this for application code where you don't need to tell the caller what precisely went wrong. Interesting. So let's look at anyhow, just to see how popular it is. Dang! Sorry if that was really, really loud. 140 million downloads. I would say this is a thing. That's one reason I like to come to package managers and like look up when I get recommendations is like, how much is this actually used? So, yeah, wow. Okay, that was crazy. Yeah, that was crazy. Okay, all right. Use SERD for deserializations. Instead of deserializing the entire response into a SERD JSON value, you can define a structure that represents the data structure you expect. And that's what I had planned to do. We're not going to get that tonight. Probably do that next week. You expect to receive from the API. This makes your code more robust against changes in the API and provides better type safety. You can then use SERD's derive functionality to automatically implement the deserialized trait for your struct. Blah, blah, blah. We know. Here's how you could apply these suggestions in your code. Okay. Anyhow, result, request blocking client. Okay, that makes sense. I'm doing that. SERD deserialize. So derive, yep, we know that. Main, result. So client.new, interesting. We're going to get it. We're going to send. That's interesting. That's interesting. Why are we doing that? Let's ask. Let starship response equals JSON, because we're going to use the starship up there, and then print the starship. Cool. Makes total sense. I get it. Good improvements. The anyhow is very, very interesting. So we're going to use an anyhow result. That's what we're expecting back. Okay. Still not 100% sure on this. We'll add that to something to dig into later. But I am curious about this. Why do this instead of how I implemented it? It seems odd to define a client, then call get, which I mean, it really does make sense. The confusion comes with the send. Why the send? In the request library, the client struct is used to create. See, that's a mind changer. Client is a struct with an implementation, not an object or not a class. Something I've got to get through my head from Django land, or from Python land. The client struct is used to create a new HTTP client. The get method is then called on the client to construct a new get request. However, this doesn't actually send the request yet. It merely prepares the request. The request is only sent when the send method is called on the request builder. The reason for this design is to allow more flexibility and control over the request after calling get. Okay, that totally makes sense, that it's just building up the request that needs to be sent and we have to call send. I totally get that. That's a great implementation piece of information. You can chain additional methods to modify the request, such as adding headers, setting query parameters, or specify body for the post request. Once you're ready, you can just call the send. Makes sense. I get it. And I'm sure you could do like a client dot headers equals blah. That would make sense. Here's a simple analogy. Think of the get method as buying a ticket to a concert and the send method as going to the concert. Yep, buying tickets doesn't mean you have to go to the concert immediately, but once you're ready, you can decide, blah, 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 we're going to go. But calling send is actually sending the request. Get it? Makes sense. I understand. Cool. I think this was a good first round. I learned several things. Hopefully you all did too. I like this form of learning. This type of learning would not have happened a year ago. I think using AI to have this conversation to really dive through the code, because now this code makes a lot more sense. Still not 100%, used to the box data structure, but the result, I kind of understand that, but we're going to work on that. Using the request, using derive to deserialize and serialize. I just understand it better. And so I feel like I'm a little bit further. What's going to really kick my rear end when we get there is the borrow checker and trying to get past some of that. But I think we can do it. Again, I think this is the first good week, and I will see you next week, and hopefully that time it'll be live streamed. And in the meantime, go ahead and like and subscribe, and stay tuned for more, because I would really like to use this for a long time to learn and get better at Rust, and take a few of you along with me. If this does get big enough, I might do other stuff with it. But for right now, I plan on this being a weekly live stream, and to learn Rust and just kind of pick up wherever we go and just kind of meander through Rust as we learn. So with that, thank you for your time, and I will see you next time where we can do more Rust. See you later.